Subscribe to Shubham Technical for latest technology video. Click on bell icon for latest update of technology videos.
Hello and welcome to this session. This session is dedicated to a 4x4 matrix keypad. As you can see, we have this keypad connected to Arduino, and we have also connected our LCD, which we have already seen in our previous videos. So this keypad is very useful for entering data for any embedded platform, because we don't normally use a regular keyboard for embedded applications. A keypad is quite useful one. So we can enter, this can be used for entering suppose password protected applications, a keypad to access dialers. Suppose we have a phone dialer application, or maybe in games we can use for game controls. As you can see, the numbers doesn't matter, you can label them whatever you want. For here they are labeled as 1 to 9 ABCD star 0 and hash. Fine, so let's move ahead, and for this experiment we will simply use this keypad to display characters and numbers, the labeled numbers on LCD screen. So this idea can be extended to any application. You can interface any input device, any temperature sensor output, anything you want, and show it on LCD. And the keypad can be used to, as I mentioned, for various other reasons. So you have 16 input keys, and you can see we have 8 lines coming out from keypad, and 4 lines are for rows. So these are for these 4, that is 4 to 7 are for rows, and 0 to 3 are for columns. So we'll see in detail about rows and columns. And now coming to our live video feed, here the same circuit is made. I already extend our previous circuit, and here you can see we have our matrix keypad. The same way it is connected from 0 to 7 in digital input output pins. So let's get into programming. So unlike other inbuilt libraries, keypad library isn't available out of the box, so you have to download it from playground.arduino.cc code keypad. So this is a community made library, and very stable, though I have used it personally for my experiments, and it is made by a person named Alexander. So thanks to Alexander, we need not to write a complete keypad routine, which is very useful for us for any input operation. So before we move further, first we have to download this keypad.zip file and install it. So I will just click on this keypad.zip link, select OK. I have already saved it, so let me download it again. Once downloaded, you can go to Arduino IDE, select Sketch, include library, and you have to go to add zip library. Here you have to select where you have downloaded this zip file. I have downloaded mine in 5.5. You can see keypad.zip. Select OK, and you can see here the library, it says library added to your libraries. Check include library menu. So go to Sketch, include library, come right way to the bottom. You can see contributed libraries, keypad, and you have keypad.h. So from next time onwards, you need not to go to libraries if you wish to, and you can simply type #include space keypad.h. Coming to the documentation, as I mentioned, you need not to remember and you need not to worry about the syntax of the program. You have to go through the documentation. The documentation clearly mentions that we have these inbuilt functions this library provides: void, begin, wait for key, and etc. We will use them, but let us first find out what are the different constructors required. So we have to create a keypad object, as you can see, keypad object, which uses the row pins and column pins. So let me maximize this window for a while. Okay, so yes, so first you have to create a keypad keypad object, create a keypad object, and that keypad object will contain values for rows. You can see here rows, columns, the row pins, and other details. So this we will see right away, and then simply, in fact it's better we see an example which will give you more insight. You include the library like mentioned here. Here they have mentioned constant byte rows equal to 4 and bytes constant bytes columns equal to 3. This is because 4x3 keypad, ours is 4x4, so we will use 4 and 4 here. Character keys, rows, columns, so these are array which tells that which numbers are labeled, which characters are labeled on the keypad. So in our case it is labeled as 0 to 9 star hash ABCD, and here ABCDs are missing, but in our case we had ABCD as well, right? So you have to tell Arduino that what are the key mapping, how they look. So this is just key mapping array. Next you have to tell Arduino that which pins are for rows and which pins are for columns. So we already know that keypad is connected through 8-pin header, and 8-pin contains 4 pins for rows and 4 for columns. And in our case we already discussed 0 to 3 is for columns and 4 to 7 are for rows. So we'll replace these values here. Here they have not shown any interfacing with LCD, they have shown interface with serial device. So serial device comes in our later chapter. Although this is a very trivial example, we will go a little bit ahead and display it on LCD. So I hope you understood this example. If not, anyway we will write our code and we will discuss there again. So bringing this example on, let me write the code. So I have paused the video and wrote this code for you to save some time. And as you recall, this liquid crystal is creating a object for liquid crystal class, and here we have the key mappings, like we have this 4x4 keypad, so 4 and 4, and here are the labels which appear on the keypad. So this is to tell microcontroller, this is to tell Arduino that this is how the keys are mapped, and this is how you have to find out the key pressed. We are seeing another array of row pins which Arduino's digital input output pins are connected to rows, as I mentioned, 4 to 7, you can see here. So 4 to 7 is connected to rows and columns 0 to 3. So we need not to discuss the internals of the keypad. You can just simply imagine it's a 4x4 matrix layout where each node, each junction contains a momentary switch, and based on the algorithms we find out which key is pressed. So that those algorithms are of course mentioned in this keypad.h function. Then we have to initiate an instance of class keypad. So simply initiate the class keypad, name the object as my keypad, and here we have let me expand this. So here we have called this keypad function, and which takes the values from make my keys, this key maps, row pins which is 4 to 7, column pins which are 0 to 3 digital input output, and 4x4 matrix keypad, so 4 and 4. So we are not using variable here, we are directly giving hard-coded values, and this is good enough to start with. And now, because these are all globally declared, Let's declare our void setup, and as you know, in the void setup we have to mention lcd.begin. What kind of LCD we are using? 16 characters, 2 rows. We want to use all of it. Okay, there is nothing to initiate the keyboard. Keyboard we already initiated. Now coming to void loop. So here we have to define a character type variable key, which will receive from my keypad dot get key. So get key is the function which probably you have seen in our let me show you here. We have a syntax to get which key is pressed using these inbuilt functions. Let me show you the function. We have the function character get key returns the key that is pressed. This function is non-blocking, so it won't block any other running programs in the backend. Suppose you're blinking an LED or receiving a serial data. So this is a non-blocking function. So this returns a variable key. The value stored in a variable key. And if I'm writing this according to the documentation only. Sorry, if key not equals to no key, and there is an if condition. If this is true, then lcd dot set cursor 0, 0, and lcd dot print key. I think that's it. It should print whatever we type on keypad. So let's bring the video on. Let me resize it. Fine. So I will press Ctrl U to upload. Save the file. Okay. So name keypad is. Oh, I probably accidentally removed the keypad. Hash include keypad.h. Ctrl U to upload. Extra curly brace. Void loop. This one goes for function. I think that's it. Upload. Fine. Compiling sketch. And no display on screen because we have to press a key. So I'm pressing 5. Yep, it works. 4, 7, and so on. Now you may ask me why I have written here if key not equals to no key. So for even the documentation doesn't say on the Arduino page, the documentation doesn't reveal what is this no underscore key, but if you go through the source code of this library, you will find this no key is nothing but null character. So what is a null character? Null character means it's a terminating character. Null character is this. So this is a null character in C and C++ programming language. This is used to tell where the string terminates. So this is how the compiler knows where the string terminates. But here we don't have any string, but this keypad library uses this null character to print non-keypad values. So we have these keypad values. Our keys are labeled like this, 1, 2, 3, A, and etc. If these keys are pressed, it won't print null. If any other key is pressed or nothing is pressed, it will print null. So just remember how it works. I think you already understood some part of it. Let me explain it further. So this void loop is an infinite loop, as you know, right? So indefinitely it is in a constant while loop, it is constantly receiving a key press, right? But if there is no key press at all, suppose at this time I'm not pressing any key, okay, it is completely idle, but still it is polling, it is finding out whether key is pressed or not, key is pressed or not. So this loop is very, very busy in finding out whether key is pressed or not, key is pressed or not. And while there is no key pressed, what it prints, it has to print something. Maybe the library is designed in that way, it has to print something. For that it is printing a null character, okay. So this null character is printed when there is no actual key pressed. Fine. So we are this function, this conditional look for the null character, and it only prints the numbers which are mentioned on the keypad. So it ignores when there is a null character, and it only prints when there is actual character. Actual character means one of these. So to prove that this is a null character, so let me do one thing. It might take some time, but it's very important to understand this. Let me replace this no key with a null character. Okay, so let me upload it again. Done. And let me press the key. So I press 6 and you can see 6. So this no underscore key is nothing but a null character. So I'm doing the same. So now some of you might be thinking that why not we just make key equals to, or instead of not equals to, let's make it equals to equals to. So let's see how this null character looks on our LCD screen. So this means print everything. Means if you get a null character, print only null character. Okay, so let's do this first. So here you can see there is a unidentified symbol. It's kind of garbage value, and that's all. That's how this null character looks, because this null character is not defined in our keypad LCD database, LCD list of accepted symbols. So it is defining it something like this, broken 5 or whatever. So this function now tells that print only if there is a null character. Suppose I now press something else, it doesn't change because it ignores 7, it ignores star, it ignores 0, etc. Right? Now you might ask me, why not we just make a else statement and print our other characters. If key equals to null character, then print this garbage, else. So let me try this, else. So let's lcd dot set cursor. So let me make it to second row, lcd dot print key. Fine. I'm doing a lot of mistakes today. Uploading and done. So it still prints the garbage value, but you can see in the second line when I press a number, it prints 7. When I press 4, it prints 4. Okay, so what does it mean? It means when there is no number pressed, it by default print a null character which is unidentified for our LCD. If and key is pressed, a regular key is pressed from keypad, it prints the key. So our original function, let me undo all these changes. So this is the function which we got from the documentation, right? Key not equals to no key. So no key is null character. So whenever you find character which is not null character, print it. So what are not null characters? Our numbers, our keypad numbers, right? Fine. So let me make small modification. So instead of using LCD set cursor which replace the number there itself, let's use the another function for LCD, which let me show you on documentation. We have this left to right. Okay, so like it will print on screen left to right, LCD left to right, and this function doesn't take any argument. Control U, cleared. Okay, so now you can see this cursor moves to the next available space. Okay, I hope you have learned something from this chapter. You can go through the keypad and LCD libraries and do more experiments, and of course you can interface many more input devices and use and make many more exciting projects. So that's all for this keypad session. We'll see you in next video.